Okay, so this is the second part of the geometric series. So we're going to be taking a look at how do you find the sum of an infinite series here. So again here, we're going to look at this like we used to look at exponents. So in the other chapter, I think it was chapter 6 or 7, we had equations like this. And we had to figure out if this is a growth or a decay, right? So again, we said if this number is bigger than 1 like it is, this is a growth. Right? So if it's a growth, this means you don't know where it's going to end up. Since it's going up forever steeply, the last term, you don't know where it's going to be. So in this case, you would say this diverges if it's a growth. And since it diverges, it keeps getting bigger and bigger. If we go to infinity, we can't, when we add up the numbers, it's going to go to infinity. So if you're trying to find a sum of a infinite series and your r here, so our r here is greater than 1. This diverges. So this means our answer here is the sum does not exist. Sometimes you'll see them shorthand this as DNE, right? But so our sum, if it diverges, so this in this case, our r is bigger than 1, or absolute value of r is bigger than 1, so it's going to diverge. So it's going to go to infinity. So since it's going to infinity, we can't add up the sum. So our sum does not exist. Okay, let's look at another example. Okay, here's a different example. Here, we're going to go from 1 to infinity. This time, this is our y-intercept. Sorry, it's going to be shifted, right? This is our A1. This is our rate. So our rate here in this case, our rate here is less than 1. So we know this converges. So it's gonna go down towards 0. So since at the end we're just adding zeros, we can figure out what the sum is here. So we're gonna use our formula. So we have Sn. So we have an infinite series here that converges, and we can only find the sum if it converges. So in this case, since our r is less than 1, we're going to use a1 equals 1 minus r. To get the first term, we're going to plug in the first term. We're going to plug in 1. So we got 3 times negative 1/2 to the 0 power. So negative 1/2 to the 0 power is going to become 1. So we got a1 equals 3 negative 1/2 to the 1 minus 1 for a1, which is 3 to the, and this becomes, anything to the 0 power becomes 1. So your first term is just 3 in this case. 1, and our r here is negative 1/2. So we got minus negative 1/2. So then we can just punch this into the calculator. Let me pause while I erase this other side. So we got 1/2, 1 plus 1/2 is 3 over 2. We're going to keep changing flip. So this is going to end up as, your sum is going to end up being 2. So again, you can only find the sum of an infinite geometric series if your r is less than 1. So that means it converges. And if it converges, you just need to figure out what your first term is by plugging in the first number here. So if this was 2 down here, you plug in 2. Since it's 1, we plug in 1. We know the rate here is the 1 in parentheses. We plug it in, and then we're going to solve for our sum here.